Hi, this is Silvia Mazzoni and welcome back. Congratulations for making it to the fourth and last part of this video series on benchmarking HDF5 format. In the first video, we learned about the basics. In videos 2 and 3, we did some benchmarking based on either data types or structure. And in this last video, I'm going to do a summary of what we've learned and my recommendations based on what I learned from the benchmarking exercises and keeping in mind what my application and use is. Here's my quick summary plots and quick statements, and I'm going to get into a little bit more detail in my recommendation. So with data type, we definitely have a reduced file size when using non-string data types. So it's better to represent numbers as numbers instead of strings, which is kind of obvious, but it also tells me, hey, maybe HDF5 files are not the best way to go if I'm trying to store text. I'm not gaining as much from my string data versus my numbering data. We do have a speed up in writing time as well, not just in file size. In read time, there's, the difference isn't significant. And then when we're looking at data structure, hey, you know what? You can structure the data at no extra cost. And what's nice about structured data and the advantages of it, remember, is that you don't have to load the entire data set into memory. So you have it structured and it's easy to read. What we've learned from looking at the data structure, whether we separate it into many different files or one big file, is that there is a limit where we lose efficiency when our HDF5 file is too large. Okay, so let's look in summary at the two benchmark studies. First, file size. So on the left-hand side, we see that when storing NumPy arrays, we have a definitely improvement in performance on file size compared to dealing with AT2 files or individual ASCII files. When your data is string, it's really not so much you can do in improving your efficiency. If we look at the grouping, what we learn is that the file sizes are the same whether you put in additional information and structure or not, or if you're dealing with 3 different files versus one big file. So file size is not affected. And so if that's an important metric to you, yay, this is an important metric in defining your design. If we look at write time, which is these two figures on the right, what we see in writing time is that writing to NumPy data is definitely more efficient than writing string data. And if we look at the data structure here, we see that if we have up to a certain point, structured data is worth the extra steps because it's not costing you anything in write time. What is costing you is when you're writing to really large files. You may want to consider grouping your data into different files when you have a significantly large number of data sets. Then if we look at read time, well, read time is definitely faster when we're dealing with NumPy arrays than if we're dealing with strings versus dealing with ASCII files. You do have a significant improvement because it's already formatted if you put the data into your HDF5 file. So even if you have string data, you definitely have an improvement, mainly because we've already processed it. Plus, remember this point right here is that to access that data, you don't have to unzip or open up the files one at a time. So even if you have string data, it's worth it for read time to organize it in an HDF5 file. If you have NumPy data, there's definitely a significant improvement in read time. So it's definitely more efficient to keep everything in one file for read time. However, our second benchmark test showed us that yes, it is more efficient up to a certain point to have everything in one file, but then when your file size gets too large, then you definitely have improvements in performance if you group your data into smaller files. And so this data is what applies to my data set. You may find different results with your data set. And so I always recommend doing this kind of testing. And you saw that it's 2 types of benchmark testing. Maybe you have some additional benchmark testing that you might need to do for your design. And then you look at these and you almost score and you weigh. It's like, oh, okay, well, everything here, though, to me, leads me to go to this case right here in red, because I see it that it's a performance gain on all fronts. So organizing my data into smaller files and then even using grouping really helps. This is just a little screenshot to show you how fun it is to look at when you're doing this benchmark testing, the file sizes Okay, this is based on data type. The format, you've got 16.5 with 60 files, and then you've got almost the same amount if you have the string data versus exactly half if it's NumPy arrays. And the other interesting thing to look at here is that from 10 to 100,000, this is not proportional. So this should be 40 million. And so you do have improvements in efficiencies as you increase the number of files, as your files get bigger and the data gets bigger. And so this is really the point that I was making very early on, that if you have a small amount of data, it's easier to manage it locally in just whatever is easiest for you. When you have large data sets, then you might want to step it up and bring in tools such as HDF5. One thing to keep in mind is that these are dangerously big files and they're binary files. So as much as you need a backup of this file, you can keep this backup in a much cheaper location for storage. Couple of notes that are important to point out, especially as you move on to your own benchmarking, is I have not looked at these different items. One is compression. But what I've learned is that using compression doesn't always yield smaller files. I tested it and it didn't work for my files, mainly because maybe my data sets aren't that large and they're not easily packageable, which is where compression comes in. And it does slow down reading and writing performance. So this is something that you should look at. Are the benefits of compression worth it to your application? It didn't work out for me, so I removed that from my benchmark. Also, another important thing is the drive type. I didn't vary it. I was working with external disk, so this was actually the slowest way of doing it, but I don't keep my data in my C drive, and the data location was the same for all the benchmarking, so it was not a variable in my test, but that's something that you might want to keep in mind. Maybe you might want to work on the data in your local hard drive, maybe it's a steady state drive, so that'd be a lot faster to read and write, and then move the data to a USB disk. So that's something that you can gain, but for me, it wasn't something that I wanted to study in this benchmark test. The other thing is the interpreter. I only did things in Python. Maybe working with R might work better. I did this in a Jupyter notebook as well as in the Spider IDE. Maybe working on it from the command prompt may improve it. And so there are things that you can do to improve your performance, but those were, for me, there were fixed constraints. This is what I wanted to work with. And so I wasn't worth for me to look at the effects of changing that. Also, another thing you might want to take advantage is concurrent processing. Once you've decided on your design, then you might want to take into account maybe being able to do things with concurrent processing, especially if you're writing to different files. And so these are additional things and additional notes that you should consider in your study. And this leads me to my recommendations. I like to give recommendations here and there. So let's see if I can bring this into something cohesive. So when to use HDF5? HDF5 is great for structured data when you've got files like what I'm showing you in this figure. It's great if you want to store many different data objects of different types and sizes in one file. Key being one file. It's great if you don't need to query the content, you just need the name and the metadata. Even though you can filter on it, you can search on it, but it's not something, oh, I only want, these sets of data. And it's nice because it's become self-documented because it's like a dictionary. And also keep in mind that it's great when your data is static. If you're changing the data, then the memory allocation kind of gets messy, and so you don't want to use HDF5. And if your data is nicely organized in tables like this that you want to query, maybe you only want this segment and certain data sets, so maybe you might want to consider other more efficient storage options, such as Parquet or database or even CSV files. Okay, the nice thing about CSV files is that they're ASCII files that are readable by a human, which is sometimes just a really nice thing to have. It's a great way to checking your data. And in this case, though, you may have to work with many files, one per table. And that's something that you need to take into account in your decision making. So my conclusions, I think that HDF5 format files are great for storing and retrieving data, especially binary data. What I've been showing you is working with ground motion files, but you can actually store images and other types of data sets. They're not meant for managing metadata. It's not meant to be used as a database, even though you can access that data. And so what I recommend is that you manage the metadata in either JSON or database format for ease of querying. And then from there, you get the key where to grab the data from the HDF5 files. The key advantage of using HDF5 is that you're not loading the entire file contents into memory. Okay, that's what you have to do when you're working with JSON. You upload a file, now you have it in memory, and the HDF5 is more like a bucket. You go in, you stick your hand in there, and only grab the data that you want. And that's really the key advantage of it. Very important to have some thoughtful design a priori. Make your choice of the file structure based on your application and usage. Read the documentation. I've only given some highlights here. There's different options that you can put in both reading and writing and storing your data. And always test your implementation with your configuration options and check the scalability. And then you go in and set things to run. Because remember, you wanted to use this format when you have a lot of data. And just my usual thing is sometimes you can get somewhere faster on foot than you can by car. So think about what is the optimal application for your case. My additional recommendations that HDF5 is ideal for ground motion files. You can store many recordings of variable length in one file. You can organize the data to be self-documenting, which is a wonderful thing with this type of data when you have different data sets. You load memory only the records that you request. So oftentimes you only want, maybe 10, 11, 50 records. And so you're loading into memory only what you need for processing. And you do not need to query the data itself, even though you can filter it. And that's what I'm saying here. You can query on the metadata, which is called attributes. And remember, this is great because in ground motion files, the data is static. And that's something important to keep in mind. There's a significant reduction in file size by 50% when compared to the AT2 files. So I'm definitely going to go this way. And then I've got to decide, what are the subtleties on how I'm going to go this way. I mark these in pink, and even though these should be marked in red, here, these are the things to keep in mind. HDF5 is binary data. You can't just visualize the contents humanly, okay? So it's a little bit of a pain because I like being able to look at my data almost in Excel and being able to see if things make sense, and especially if I do have data. And so it takes an extra step to check the content. There is a limit to the scalability. We've seen that. And so you may need a few, not too many HDF5 files. Look at your application and always have backups. One file corruption destroys the entire data. But what's nice is that you can keep the one copy of your file in your working directory, and then you can keep your backup somewhere else. So they don't have to be in the same location, and so you can store it somewhere where it's cheaper. Congratulations for having made it through this whole series on benchmarking HDF5 format. I hope that the basics were useful, as well as the actual process of benchmarking based on data types or structure, and then the recommendations that I put together based on my experience and what I can pass on to your applications. Remember, you've got to do some testing and thinking ahead of time, and that's going to save you a lot of rewrite time. And again, and I can't emphasize this enough, the design of your structure should really be driven by performance as well as your ultimate application of your data and your uses. Well, I hope this series was helpful, and leave me any helpful comments in the comment section. Bye-bye.